is a delight to be here with you all, sharing some ideas about what I find to be one of the most fascinating topics in maybe all of technology. What a time for what we call AI or language AI. It's been a roller coaster ride if you've been paying attention the last few years. And this is a pattern that you can see just in computing in general. Every 10, 15 years, we have this sort of new paradigm that opens up new ways of doing things. So the rise of the personal computers, the creation of the web browser, the smartphones. Every one of these just creates new ways where people can communicate with computers and ways they can use them. That also changes definitions of jobs, entire industries as well. And now we stand at this era or time where this generative AI or AI in general or possibly generative chat are this new mode that is probably going to be as big as these previous technological shifts. But I even sometimes like to take a further step back and say, if you look at the human species in general, jumps in language technology can be milestones for the species as a whole. And you can point at the invention of writing, which is just this jump in human language technology. And that's technically what we call the beginning of history, is this one sort of jump that we use language in a specific way, and then that's what we call history. And then about 400 or 500 years ago, the printing press, this device sort of made it possible for people, for so many people to have books. Before this invention, if you wanted a copy of a book, you needed to go and copy it yourself or pay somebody to copy it by hand. So once this way of automating books came around, you didn't need to be rich anymore to be able to own a book. And then that sort of opens the door for the next technological revolution, the Renaissance. And pretty soon we're just launching Teslas into space within the span of a couple of hundred years. So I have talks from 2 years ago where I say, this jump, is it going to be as big as these two? We don't really know. There's a lot of hype, and I would like to cut through the hype. But 2 years ago, I would say we have a less than maybe 20% chance. It's possible that this is going to be as big. Now I put it at less than 40% chance. So it's definitely going to change so many different things, but we'll see if it sort of lives up to these two. So my name is Jay, and I blog for about the last 9 or 10 years about machine learning and language processing and large language models. The most read article is the Illustrated Transformer that explains this neural network architecture that sort of launched this explosion in AI capability over the last few years. It has about 3 million page views or so. I'm the author of this upcoming O'Reilly book called Hands-on Large Language Models. So we're targeting releasing it in August. It's already, you can find the first 5 or 6 chapters on the O'Reilly platform. And I work at Coher. And Coher is a large language model company. It's one of the earliest large language model companies. They've been training these models for about 40 years. And it was started by one of the co-authors of the Transformer paper, Aidan Gomez. And so I joined because I was absolutely fascinated about this technology, and I wanted to see how this cool machine learning trick would make its way into industry. How will it become products? How will it become features? And that's what we're going to be sharing here. Some of the things that I learned sort of from what we see in Coher and sort of how people sort of adopt these products. And so you're definitely in the right room, in the right place. This is the right time to start to think about how to build the intelligent systems of the future using technologies like these. Now, when I used to go and give talks 2 years ago, I had to introduce to people what a large language model is. That was not a common piece of software knowledge. But now everywhere I go, developers or non-developers, everybody has interacted or have some sense of what is a chat model, what is a chat GPT, what is a large language model that you sort of can talk to. And so how we talk about them is a little bit different. So now what we try to do is to try to raise the awareness that, okay, you've interacted with a generative chat model, a large language model. We suggest that you don't think of it as a black box. We suggest that you don't think of it as a digital brain, regardless of how coherent and how well written it might be. The useful perspective we advise everybody, and developers specifically, is to think about it in terms of what can you build with this? What kinds of capabilities did this sort of give you or add to your toolbox as a developer? And so how can you think about it more than just this box that you send some text in and you get some text out? And that's what we're going to be talking about here. And so when we talk about the language side of it, you can talk about two major families of capabilities that these models bring to you. And these can be language understanding capabilities. That's the first group of capabilities that language models provide to you. And it can also be language generation capabilities. That's, let's say, the other group. And even if you're not dealing specifically with text generation, who in here has saw Midjourney or Sora for like image generation or Stable Diffusion for video generation? So all of these models, even though they are generating things other than text, they have a language model embedded in them in the beginning of that flow because you're giving them a prompt. And that understanding of a prompt is the use of a language model for understanding, not necessarily for generation. And so for your toolbox, I want to break this down further. So generative chat is only one of multiple things that you can do with generation. So text generation can be summarization. So taking a large article and providing a 2 or 3 minute, 3-sentence summary is a generative task. Copywriting, if you tell the model to write me an email that says this, or write me variations of this type of text, or that's another sort of generation text. And these are in addition to generative chat. So one of the main messages here is don't be limited to chat only. Like everything you can do with generation can go into a lot of different generation tasks. And a lot of them should probably be offline. You shouldn't always sort of lock yourself into, I'm going to be always thinking about online chat right this very minute. And then even when you think about these other non-chat generative capabilities, you're only thinking about one of the things that AI can do. In fact, some of the most dramatic and most reliable use cases that AI has right now that has even progressed the last few years are things like search or text classification or categorizations. And large language models, or language models in general, small and large, are some of the best tools that we have for that. And so think beyond just generating text. I think it's a little bit unfortunate that this wave is being called generative AI because some of the most robust applications are really more on the understanding, the representation, the search systems, and we'll talk about these and sort of where their capabilities lie. And so this idea of search by meaning or using a language model for search is one of the most reliable applications of large language models. And if you've tried to build with large language models, reliability becomes something that you sort of care about a little bit because there's so many cherry-picked examples that you come across in social media, but if you try to build that into a product, you realize that that works 6 out of 10 times or 3 out of 10 times, depending on that use case. And so reliability is important when you think about sort of robustness. So when you think about search, don't think only about building the next Google search. Search is this major feature of every application that you interact with. Every company needs to search their own internal documents, and a lot of search systems are broken. They need to be sort of improved. You can almost never find what you want. And how language models can help here is with this idea of semantic search. So let's take a query, for example. So you want to search for Brazil to USA travel. So before language models, most search was based on keyword relevance. So it will break it down and compare the keywords in the query to keywords in the document. And if a system is not very well tuned, it might give you this article, which has all the same keywords, but the order of the two countries is flipped. And so that document really does not become a relevant document for that search. But if you use language models for that search, they have a better ability to sort of catch the intention and the context that you're using these words for. And so that's the idea of using language models for search. Two main concepts to think about for semantic search or using language models for search. One is called dense retrieval. Who has built anything with embedding search, like a vector search database or Pinecone? Okay, so we have a good number, I think maybe 30, 40%. So that is what's called dense retrieval. And then the other one is called reranking. Let's take a quick look at how those are. So you have a query, you send it to a search system, in this case a vector database, or it can be a database with vector search capabilities. So there are features of Postgres, for example, that can do something like that. And that vector database has access to a text archive, and then it produces a number of search results. So this is the search formula, basically. Behind the scenes, how dense retrieval sort of works is that it takes the query, it sends it to a language model that provides something called an embedding. So language models, you can have them generate text, but you can also have them generate another thing, which is a list of numbers that capture the meaning of that text. And that's what's called an embedding vector. And so here you have the query, you send it to the model gives you maybe 300 numbers, like a vector size. That is a numeric representation that is useful for downstream software applications. And then you simply send that vector to this vector database, and it finds the nearest neighbors to that point, and those will tend to be the best search results for that query. And this model sort of has to be tuned for search specifically. You can't just get any embedding models. An embedding model used for search has to be tuned in a specific way for search. There's a step before that of chunking the text and embedding the archive beforehand, so that is step 0. If you'd like to play around with embeddings, we've open source, we've launched, released the embeddings of all of Wikipedia. These are 250 million embedding vectors of Wikipedia in 300 languages. So it's the English, but also every other Wikipedia out there. It's on Hugging Face, you can download it and sort of play around with it. You can build incredible things with it. And so that is dense retrieval. The other idea is called reranking. And reranking is really the fastest way to inject the intelligence of a language model into an existing search system. And it works basically in this two-step, let's say, pipeline. So you don't have to remove your existing search system. So if you're using Elastic or any other sort of search system, that can be your first step of your search pipeline. And that is the system that queries or searches your million or a billion documents and gets you the top 100 results. And then those 100 results we pass to a language model, and it just changes the order. It outputs the same 100, but it says, this article that you told me is number 33 is actually the most relevant to this query, so I'm going to make it number 1. And so this is only one call at the end of that search pipeline that tends to dramatically improve the search system, regardless whether you're using Elastic, whether you're using embedding search, whether you're using hybrid search of the two. Just re-ranking just gives you that uplift sort of very quickly. The way that it works is this is a language model that works in what's called a cross-encoder fashion. So to the language model, we present the query and the document, and it just outputs a score of relevance. And even if you're familiar with embeddings, this works better than embeddings because the language model at the time of scoring has access to all of the text of the query and of the document. And so it's able to give a better result because of that information that it has, while embeddings actually work on these very compressed spaces of the two vectors that can't encode all the information in the texts. So that's why re-ranking tends to work better than embeddings, but it happens to be a second stage because it can't operate on a million documents. So you need a funnel to choose the top 10 or 100 results to give to it. And here you get to see the uplift that you can get. The light, these are 3 different data sets. The light one is keyword search, so that's Elastic or BM25. The one next to it is kind of like this one. This is search by embeddings, and this is Elastic plus re-ranking. So whether you're using keyword search or embedding search, a re-ranker sort of is one of these fastest ways to improve the search system that you're building with. Now, the y-axis here is accuracy. Who here is familiar enough with what that means? What is search accuracy? Okay, that is very good, because I have a couple of slides on what that means. But because coming into this, I saw a lot of people wave hands about search accuracy, but I wanted a clearer definition. But we'll get to that. And so these are two kinds of language models. So these are not generative language models, but these are ways of using language models for search. Embeddings and re-ranking are these two ways. And so even if you're interested in generation specifically, search is one of the most important things for the future of generation models. And this is an example that showcases why that is. So let's say you have two questions. You have a question where you send a question to a language model, and then you have another scenario where you send it the same question, but you actually give it some sort of context. You maybe give it the answer before you give it the question. And question number two, like models would tend to answer number two better than number one. So regardless of the question, like if you give the model the answer plus the question, it will probably have a better answer for you. And this is one of the first things that people sort of first realized when these models came out. They called them, search killers, and people were asking these models questions and relying on how factual their information are. And a lot of people got into trouble for trusting how coherent those models are and ascribing authority to their information sort of retrieval. But then that turned out to be a mistake, and everybody now knows about this problem called hallucinations. Models will tend to give you an answer. Maybe they might be a little bit too confident about it, but you should not rely on a language model, specifically only a language model, for factual retrieval. You need better tools. You need to augment it somehow. And that is the method here. So when you're relying on the model for information, you're relying on information that is stored within the parameters of the model. And so you're always going to be using larger and larger models. The information is always going to be outdated, because how can you inject new information into the model? Do you have to train it for another 9 months? While in this other paradigm, you actually augment the model with an external data source where you can inject the information at question time. Whenever sort of somebody asks you, the model is able to retrieve the information that is needed, and then that informs it. And you get so many different benefits from this. So you get much smaller models because you're not storing ridiculous amounts of information in this inefficient storage mechanism and loading them to GPU memory all the time. You can have up-to-date information. You can change it by the hour. You can give different users the ability to access different data sources. So even it gives you more freedom of what systems you can build with a system like this. But it also gives you explainable sources. So which documents did the model look at before it answered this question? That gives you a little bit more transparency into the behavior of the model. And then that can also help you debug, did the problem come from the search step or from the generation step? And so this is what retrieval-augmented generation is. It is this intersection of search and generation. And it's by far the highest in-demand use case that we see in industry and enterprises that we talk with. And one way to look at it is kind of like this. Command is the LLM we use at Coher, and you're tying your LLM with a data source that is able to access and sort of retrieve information from. So this is one way of thinking that the conversation is not just with the model itself, but it's with a model that is connected, that is grounded in a data source, that is able to access that information. And so now you have these two steps. So before the question is answered, it goes through a retrieval or a search step, and then you go through a generation step. So these are the two sort of basic steps of a retrieval pipeline. And then another way of seeing it more clearly is you do a search step, and then you get the top 3 documents, for example, or 10 documents. You put those in the prompt with the question. You present that to the language model, and then that's sort of how it's answered. This is also another sort of the most basic formulas of frag or retrieval-augmented generation. And then you get even better results if you have a re-ranker in this step. Because if you're only giving 10 documents and the 11th document is really the one that has the right information, but it's beyond that cutoff line, the model's not going to be able to generate the right answer. And so any improvement, the area where so many failures in RAG happen tends to be more in the retrieval side rather than the generation side. And so now you have these two language models in the retrieval step, in addition to the generation model in the generation step. And so that's one of the first ways that you can sort of build a RAG system. Now, one challenge is after you build a system like this, and because you have in mind that people will ask direct questions that can be answered with one piece of information, you roll this into production, and then you find people really ask questions kind of like this. They say, we have an essay due tomorrow. We have to write about some animal. I love penguins. I could write about them, but I could also write about dolphins. Are they animals? Maybe. Let's do dolphins. Where do they live, for example? Now, as a software engineer, is it fair for you to take this and throw it at Elastic and say, deal with this? It really is not. And this is one area, one of the first ways to improve sort of initial RAG systems, which is to go through this step called query rewriting. And this is an example of how that works. So when a language model gets a question like this, you can write a query using a language model, a generative language model that says, to answer this question, this is the query that I need to search for. And so to answer this, it says, OK, where do dolphins live? It just extracted that piece of information, and then that is what is relevant for that component, which is the search system. So now you have query rewriting as this step with a generation model. You can do it with a language model with a prompt, but in the API that we sort of build, we have a specific, let's say, parameter for it that we optimize it, but you can use it sort of in different ways. But this is how it kind of works. It outputs the search query, and then you can throw it at your search system. So now you have a text generation LLM in your retrieval step, doing that sort of initial rewriting, query rewriting step. And we'll take it a few steps further, because even the talks later in this track, you'll see some of the most advanced uses of LLMs, and we're building up to those step by step. Now, what about a question like this? If somebody says, compare the financial results of NVIDIA in 2020 versus 2023. Now, you might get this query, and you might be able to find a document that already has the information about NVIDIA's results in 2020 and 2023. But there's a very good chance that you will not find one single document that does this. And so one way to improve that is to say, actually, to answer this, I need two queries. I need to search for NVIDIA results 2020, and then 2023. And these are two separate results. You get two separate sets of results and documents back, and then you sort of synthesize them and present them to the model. And this is what's called multi-query. Another way of looking at it is kind of like this. So you have the question, you send it to the language model, and then the language model says, OK, I'm going to hit this data source, where this data source can be whatever you want. It can be the web, it can be your Notion, it can be Slack, it can be whatever is sort of relevant for you. And then the information is retrieved, and then you have this answering phase, or what's called a grounded generation. So this is where you present the model with the document in the context, and it's able to sort of answer. Another optimization for search is, what if you build this search system and somebody says hi or hello? Do you need to really search your database for the model to answer hi or hello or something like that? You really don't. And so when you're doing this query rewriting, you can build that awareness in the language model to say, I need to search for this, or I need to search for these two queries, or I do not need to make a search to answer this question. And so here, you're starting to see the model become a switch statement or an if-else, where the model sort of is starting to be controlling the flow a little bit of how to deal with this. And so it has a couple of options. So it can either search, or it can generate directly without search. as you get more greedy and comfortable with these sort of new primitives of using language models, you start to say, okay, if I can search one source, why can I not search multiple sources? Why can't I give the model the ability to search my Notion, but also my ERP or my CRM? And later and later models start to build in these capabilities, where the model can route. It's not necessarily tied to one data source. And this should give you a sense of, this is a kind of a new way of doing software. Like, it's really different when you think about these things. And you can take it even it can get a little bit more complex. Let's say you have a question like this, where you can say, who are the largest car manufacturers in 2023? Do they each make EVs or not? There probably are not one document on the web or anywhere that can answer this question. So one thing the LLM can do is to say, okay, first, I will search the web for the largest car manufacturers in 2023. So I need one piece of information first. And then after it gets that piece of information, it says, okay, now I need to search Toyota electric vehicles, Volkswagen electric vehicles, Hyundai electric vehicles. So the model is now sort of continuing to control the flow of asking follow-up questions and making follow-up searches by itself before outputting the final result. And this is what's called multi-hop RAG, where the model can make multiple jumps and sort of it's determining, is this enough information, or should I sort of go and do something else to produce this final answer. Let's take one last mental jump and to say, when you search the web or when you search Notion, you are kind of invoking a function like this. You're saying, okay, I needed to search Notion, so call search Notion, this function, and give it these parameters. Now, if you have models that are capable enough in doing something like this reliably and accurately enough, what is to prevent you from saying, okay, not only do you search or retrieve information from Notion, how about you post this to Notion? So the models are now able to just call APIs, to actually do things, to inject information, to interact with the other systems and make these sort of interactions. And now here you're starting to see this new thing emerge. Now we're beyond what LLMs are. This is a new thing. This is the LLM-backed agent. And these are some of the most futuristic things that you can see or think about in LLMs. Right now, there's a talk in this track about agents. It's never too early. They will continue to get better. But then now you're having LLMs as the heart of a piece of software that is able to read and write from multiple sources, that is able to use tools. So it can use the Python CLI. It can use calculators. It can use email. It can use other things. And so now you have this piece of software that is a little bit more intelligent. It sort of can be connected to different sort of sources. And you're starting to see more and more of what it's able to do. And it's a important piece of a place to invest in where things will go in the future. And a lot of the agents that you see right now are maybe toys, or just they show you the potential, but this will take a few months or years to sort of come through. But you can already seeing it sort of showing its potential and solving sort of problems. And it's just this extension of, if you made the jump from LLMs to RAG, and then from RAG to multi-step and multi-hop RAG, tool use is the next sort of abstraction because you're using the same thing. Instead of the search engine being your tool, it's another system or another API or another piece of software. And then we also always advocate for citations. So if you can have a system that sort of provides the citations for which spans in the text refer to which documents. We need to give our users the ability to verify the model's output, not completely trust it. And so citations as a feature is highly recommended, let's say, in building these systems. On the Coher side, we've built this series of models, Command R and Command R+, We've released the weights. You can download them. You can run them on your laptop. And they're super optimized for RAG and for all of these use cases that we sort of talked about. They're on Hugging Face. If you have the GPUs, you can probably run them on CPUs as well, but you need a little bit of memory. You can download the quantized models. But if you search Coher on Hugging Face, you can download these models and sort of start playing with all of these ideas of RAG, multi-step, multi-hop, and the final one, tool use. Developers love it, so yeah, let us know if you've interacted with it and if you have any experiences with it. And so now you have a shape like this where you have retrieval that has 3 language models in it. There's an embedding language model, there's a re-ranking language model, and there's a generation language model, and you know why that generation model is in the search step. And then you have this generation step that does this grounded generation, hopefully with citations. That will be useful. Last note on evaluation. So we talked about accuracy. So this is from one of the chapters of the upcoming book. So let's talk about this accuracy metric of search. So you have one query, you have 2 systems that you want to compare the quality of. And from each one, you'll get 3 results. Let's say you have this query, and then search system 1 gives you these results, where number 1 is relevant, 2 is not relevant, and 3 is relevant, so 2 out of 3. And search system number 2 gives you 2 non-relevant results and 1 relevant one. Who says that search system 1 is better? We have 1, 2, 3, 4. Who says that system 2 is better? We have 1, yeah, okay, it's maybe 5 to 3. So search system 1 got 2 out of 3 correct, so that's maybe a 2 out of 3 accuracy for this query, while 1 got 1 out of 3 accuracy. So search system 1 is actually better. So that's one metric of evaluating search, which is accuracy. Another one is kind of like this. What about both of them got you 1, but 1 out of the 3 as relevant, but the first system says, placed it right at the top, it said this is number 1, and the second system said this is number 3. Who says system 1 is better? And who says system 2 is better? We have a lot more for system 1, and system 1 is better because the relevance score, the relevant response is higher rated. And so there's another sort of span of metrics that sort of, and so what this assumes is that you have that you have a test suite for your data. And so if you're thinking about building RAG systems or evaluating search systems for your use case, it's good for you to develop something like this internally, which is you have your documents, and let's say you have a set of queries that are relevant for them, and then you have these relevance judgments of, is this document relevant for this query or not, for all of them. So this is how you would tend to evaluate, at least the retrieval step. For end-to-end RAG, there are other sort of methods, but this is one way. And you can use language models to actually generate the queries for that. So, and I hope by now you can think about them as just these multi-problem solving tools. And this builds up to this metric called mean average precision, which is one of the metrics that you can use for search that thinks about the scores and the ranking. So in summary, if I wanted to take away 2 things out of this, I would say, 1, large language models are not this black box of text in, text out. They are a collection of tools in your grasp. We talked about so many of these ways to make them useful for embedding, for search, for classification, for retrieval, for generation, for query rewriting. And so think of them as just this new class of software that you're able to build with. And then this idea of this new form that they're taking, this new also class of software, which is the LLM-backed agent that is able to communicate with external data sources and tools and use them a little bit more successfully and in successive steps. We have a guide on how to build something that plugs all of these tools together. You can just search RAG chatbot on the Coher blog. We have a resource called llm.university. It's I saw people missed the previous one that wanted to take a photo, but this is the RAG chatbot We have a resource called LLM.University, where we have about 7 or 8 modules about lessons, very highly accessible, very visual, with videos in a lot of them. It's completely free. You don't need to sign up. Just go to LLM.University and start browsing, and let us know if you have any questions or if we can make it sort of any more useful for you. That is the end of my talk. Thank you so much. Please vote and leave feedback.
Thank you, Jay. We have about 10 minutes for Q&A, so think about your questions. There's some volunteers in the back. So raise your hand, and then Mike will get to you shortly. But I'm going to start a question for Jay, and then we'll go from there. Given your experience in all these areas and working with regs and such, it's not easy to build reg-based systems at an enterprise grade level. What have you seen as some like best practices and pitfalls that companies or folks have run into?
Yeah. So the earlier you invest, the better, because there is definitely a lot of learning that goes into building these systems. And so having the people who experiment with these internally and sort of realize very quickly or very early their failure points is important to sort of build continually. A few concrete things are, yes, embeddings are great, but it's probably even better to have a hybrid search system where you're doing both keyword and embeddings at the same time. So you shouldn't just rely on one of these methods. And then with all search systems, you can also inject other signals into that would be sort of relevant. I really love software testing in, let's say, unit tests. I think we should do a lot more of that in machine learning. And so if you have some of that as a cache of tests that are relevant for you as behaviors, because even when you're using managed language models, their behavior might change with the next version and the next version. And so you need to bring these solid software methodologies of doing, can you catch a regression in one behavior or another? And so building those solid software engineering practices into machine learning is something that people in AI should be doing a lot more.
Yeah, it makes a lot of sense. So yeah, if you have a question, raise your hand. I know Mike will come to you. Looks like it's two.
Hi. Thanks you for your talk. It was incredible. The multi-rag hop. Do you think that it's relevant to incorporate that into the first classification call that you talked about? The rewrite plus the skip, or because it sounds very beefy for the model to understand it's actually a flow is needed. So would you separate that out, or how would you tackle that?
So like in machine learning, most answers are it depends. If you're doing a highly latency sensitive system, the query rewriting needs to be sort of the fastest that you can be. And so if that is, I think you should just measure how latency sensitive the use case is, and then go on that. And if it's highly latency sensitive, you might go with a smaller model for the first sort of step, and then for the multi-step, like you call it when you need it. So, but the entire ethos of this is to use the best tool for each thing, and not throw everything at a massive model that can do everything, but can do it very expensively. It will need so many GPUs. So yes, always advocating, let's say, using the smallest types of model that is capable to solve the task.
Thanks again. It was a great talk. What's your favorite framework? Because there's quite a few frameworks out there at the moment, and I'm going from one to the other, making POCs everywhere.
Yes, I'm in the same. I'm always trying different sort of frameworks. I cannot necessarily recommend any one right now. Like, we're working a little bit with LangChain because LangChain started soon. It just makes it convenient for people to get started with it. But I also like to do a lot of my work in just Python strings and just call the APIs and sort of build those things. So the frameworks might just make it easier for you to download a template, play around with it, see where it breaks, but don't always think that it will take you all the way to production, because it will not always do that. But as long as it helped you sort of get your hands dirty and sort of play with they're convenient to learn with. But it's still a very volatile. There's so much development very quickly that is happening. And I wouldn't say there's a sort of major dominant ones. LangChain has made its name, but there continues to be newer and newer, let's say, models that, frameworks that specialize in the different use cases, I would say, that are useful.
Question.
The gentleman here as well.
Oh, here?
Yeah. Hi. So I have a question of definitions. 1 year ago, when I learned about language models, it was quite mentally easy for me to picture that they were taught with text masses and were able to answer questions and so on. Nowadays, there's these agents and all that control logic that you were also talking about splitting questions and so on. So what's your definition of a language model? Does it include all that control logic and stuff like that? Or what do you think?
Yeah, no, that is a great thing, because even before large language models became, language model is a very well-defined, let's say, system in statistics, which is a system that is able to predict the next word successfully. That is the language modeling objective of even how these models are created in the first step. But what we found out recently is that if you train a large enough language model and a large enough and clean enough data set, it captures behaviors that really surprise you. And so if you've trained it on a data set that has a lot of factual information, the model will not only pick up language, it will pick up facts. If you train it on a lot of code and give it the right tokenization, it's going to be able to generate code. And so it becomes these new sort of capabilities based on how you train it and how you clean the data and how you optimize for it. It becomes a general problem-solving piece of software that is sort of able to stretch the imagination and do more things than just generate coherent language or text. So yeah, the nature of language models is fascinating.
Thanks for the talk, Jay. It is now. Yep. There we go. Thanks for the talk, Jay. You mentioned pitfalls, especially when people are initially playing with these kind of systems. What's one that you think you would call out that people could keep eyes open before they play? What's the one that you see as most common to people, pitfall or limitation that it would be nice to know about beforehand?
Yeah, like overly trusting the model. And this is a punishment that we get by making models that are so good. Once models became, let's say, not gibberish creators, people started to give them more authority than they should. And so that nature of it is a little different. And that trust in companies or in people who are new in, let's say, making applications for it can say, okay, I can interact with this system on this website. Let me take that same system and make it a chatbot on my public website to sort of talk with the world. And some companies have fallen into and so over trusting in these probabilistic systems without guardrails, without sort of the domain knowledge of. So yeah, just being. Cybersecurity gives you a lot of paranoia because you need to think about the different ways where your system can be broken. I think we need a lot more of that in deployment of large language models.
We have a question back there.
Yeah, thanks. And to follow up on that question, Jay, these models are probabilistic. They're not deterministic, right? So if that's the case, would you ever put them closer to your systems of record with that diagram you showed of them interacting with the world and more APIs and plugins? Would you ever put them closer to systems of record, and how long before you think that's possible or feasible?
Yeah, I mean, it depends on the use case, really. There are a lot of use cases where they are ready now. So if you're doing things that are, for example, recommendations to an expert that can sort of spot the failure modes, or if you have the correct guardrails, it's supposed to output to JSON, can you check is it valid JSON or not? So the more, let's say, you build these actual practices of that domain, yes, they can solve a lot of problems right now. But then the more high risk the use case is, the more care and attention that needs to be there. And the more we need to think about humans in the loop and sort of safe deployment options. And so, yeah, it depends really on the use case. And we know a lot of tools that increase the probability of success. There are things like majority voting, for example. We can have a model output the response 3 or 5 times and seeing, do they agree with each other or not? So there are tools of improving that, but you as the creator have the responsibility of setting that threshold and having enough, let's say, of guardrails to make sure that you get the response and the result and the behavior that your system needs.
With that, we out of time. So thanks for attending, and let's give Jay an awesome presentation.